Okay, let's find this. So these are all your quadratic inequality, your less than, your more than, your less than equal, more than equal, okay? So find the range of the values. Every time you see the magic word range, right, you have to give an answer in inequalities, okay? So find the expression where this thing is negative, right? So negative means you'll understand that this thing itself is just going to be less than 0. So we have 3 minus 2x squared, key important point, less than 0. So this is now your quadratic inequality, right? If I were to rearrange this, right, minus 2x squared plus 3 less than 0, right? I know that for my quadratic inequality, I cannot solve it like a linear inequality. Don't do it like the EMATH style. So what happens here is I'm going to make it 2x squared minus 3. And because this happens, right, I'm going to swap the signs because I divided by -1. Okay, so now from here, right, how do I actually do this? This is, you can see this as, we're going to divide by 2 first. So what we have here is x squared minus 3 over 2 more than 0. So I mean, this question didn't state that they need this in exact form, but I'm going to show you how I actually do it. This can be forcefully made into a squared minus b squared. So x, so that's a, right? So we have what though? Square root 3 over 2. Okay, so we have square root 3 over 2. Oops. What happened? Square root 3 over 2. Wait, Okay, square root 3 over 2. And then over here also, square root 3 over 2. Alright, so then it becomes a plus b and a minus b more than 0. So remember to sketch and shade from here. 3SF is fine, okay, but just show you if it's exact form what happens here. So square root 3 over square root 3 over square root 2, right? Whereas on the other side, it's positive square root 3 and square root 2. So more than 0, right? Where are we shading? We are shading over here. Okay, so what I will recommend is, because you have certs in the denominator, right? Very quickly, right? Just go and rationalize it. Okay, so when you rationalize it, so you multiply by square root 2 and then square root 2 like that, right? Here you will end up with square root 6 over 2. Okay, so you do not leave your answer in a non-rationalized form. So when we solve this eventually, right, it's actually x. Can you see this is less than? So less than root 6. Less than negative root 6 over 2. Negative root 6. Wait. Negative. Wait, what's going on? Negative root 6 over 2. Whereas on the other side, so there's a or. This side here, right? So this is more than. Okay? So we got x more than positive version of it. So this will be my final answer. Okay? It is okay if you left it in a 3SF. Alright, but you must make sure to solve it this way. Don't do the EMATH style. So your answer is here and here. Like separated boundaries lah. Okay? Okay, this one here. This one is typical. So what we have here, set of values. So set of values, range of values, same. Must have inequality. So this curve and this line, they lie entirely above. So if I were to draw my smiley curve and then the line like that. So the step one is to equate them together first. So x squared equals to kx plus k. Make it look like a quadratic. Alright, and because they don't meet at all, your discriminant come into play. So discriminant will be less than 0. So careful when you do this. This is b squared. So minus k squared minus 4ac less than 0. Okay, so what we have here is k squared. This is plus 4k less than 0. So how do you solve this? Factorize this. So k, take out your k, okay? So k plus 4 less than 0 means that you understand that it's a smiley curve. Always must sketch this. So when you sketch this already, this and this, right? This is minus 4. This is 0. Where am I shading? Less than 0. So shade below. So because I shade below, it's a bounded region, right? So pen them together. So this is the final answer. So both questions are using your quadratic inequality to solve. Okay? Okay. So now this one here, also under discriminant, I believe. Let's see. So now we want us to find the range. So again, is my inequality, correct? So inequality again. And then the thing is they said intersect. So intersect means what? Intersect means, right, that it can be intersect at one point. It can also intersect at 2 points. So that means if I intersect at one point, my discriminant is equals to 0. Intersect at 2 points, that's more than 0. So this one must be more than equals to 0. Okay, so like that. So what I have here is I'm going to rewrite this one first. So y equals to minus, maybe I do 3 minus x easier. Okay, like that. So I'm going to sub this one into here. So do as per normal. We're going to find k eventually, right? So always do substitution first whenever got curve and the line. Whether got intersection or not, you go and do your simultaneous first. Okay, so x squared minus 2. I also think it's wiser to sub in y than sub in x because at least I sub y, I sub one time only. You saw that, right? Yeah, so all this kind can, it is like preference. So you see how you make your life easier. Okay, equals to k. So I'm going to open it up. X squared minus 2x. This one will be 2. 9 minus 6x plus x squared equals to k. So when I open it up, I will get, okay, let me just shortcut this thing, okay? So I will get 3x squared. Okay, then minus 2x, then this one is minus 12. So that is minus 14x. Then we have plus 18 minus k. So what's my ABC? A, B, C. Okay, so we already know that the discriminant is going to be more than equals to 0. So you got same logic here. Discriminant, so negative 14 squared for AC more than equals to 0. Take note, it's not just more than 0, okay? So what we have here is 14 squared is 196. This is 216 plus 12k. Okay, at least this is a linear inequality, so it's not that scary, right? So you're just going to solve the k from here. Let me just fast forward. I think you should be able to see. 12k is more than equals to 20. So k will be more than equals to 5 over 3. Okay, can leave it like that. Oh, this one is just linear, thank God. Okay, so it's still a range of values, right? Because it's inequality, but linear at the end of the day, so very nice. Okay, so now you're supposed to state a possible value of k where there is no intersection, right? So you just state anything, right, that is not this one here. So what we have here is that any value also can. Doesn't have to be, did they say integer or anything? Never, right? So any value that is smaller than 5 over 3. So 5 over 3 is what? 5 over 3 is 1 point something, right? So smaller than that, you can choose k equals to 1. I mean, there's so many. Usually, I'll just give myself a whole number lah. Okay? Nice. Easy question. Just make sure you know how to solve your quadratic inequality from here.